Hi and welcome to E-ZTutoring. Today we're going to cover how to graph logarithmic functions. So there are two types of graphs you can get from graphing these functions. Your first graph, it will have a shape like this where it extends off to the right and goes on forever. This will only happen if your base on your logarithm is greater than 1. Now, if your base is less than 1, you will have a logarithm graph that looks like this. Now, the reason for this is because when you have a number that is less than 1, hence a fraction, and you put a fraction to a power, the higher the power you put on that fraction, the smaller the number gets. So that's what happens with these two graphs. Now, let's go ahead and actually graph a logarithm here. So suppose we have y equals log base 1/2 of x. So generally, to start a logarithm graph, you want to make an xy table. And by an xy table, you simply plug in values of x, get your values of y, and those are your coordinates. But in this case, if we plug in values of x, it'll be hard to tell what power we need on 1/2 to get x. So the easiest way to do this is to convert this to exponential form. I'm sure you guys are familiar how to do that, so I'm not going to dive into too much detail on exponential form. So this is our exponential form, and generally when you graph logarithms, you will plug in values of y and get your value of x rather than the other way around. So it's kind of backwards. So anyways, we start our xy table here, and we plug in some values of y. Generally, the best values to plug into your graph are 0, -1, -2, 1, and 2. So let's go ahead and plug in all of these over here and see what we get. If we plug in a 0 for y, you will get 1 because anything to the power of 0 is 1. Generally, your logarithm graphs will always have this coordinate 1, 0. So let's plug in a -1 for y now. When you have a power of -1, you simply flip your number. So now we get 2. When we plug in -2, we flip the number. So we get 2. And then we have to square it. So that gives us 4. This is simple algebra here. If you're not familiar with what I'm doing with the exponents, be sure to check out my video on all the different exponential rules. Now, if we plug in a 1 for y, we get 1/2. And if we plug in a 2, we get 1/4. So now let's go ahead and graph all these coordinates that we just found. So we make our graph here. So for our x coordinate, we have 4, 1, 2, 3, 4, and -2, 1, 2 over there. Then we have 2, -1, which is there, and 1, 0, which I said you will always have in logarithm graphs. And then we have 1/2, 1, which is right over there, and 1/4, 2, which is over there. So when you connect these dots, you will see that we get a graph that looks just like what I showed in the beginning. When your base is less than 1 and greater than 0, it will have a graph that has this pattern. So this graph will get forever and ever close to the y-axis, but it will never actually touch or cross the y-axis. And over here it will go on forever and ever. So that is logarithm graph of this equation. Let's go ahead and do one more equation. So now suppose we have y equals log base 2 of x plus 3. So once again, we follow our steps that we did last time. We convert this to exponential form to get this. And then we make an xy table where we plug in values for y to get our x. So if we plug in a -2 for y, actually, you can see that this equation is not solved for x. So if we plug in for y, we don't immediately get our value. So let's go ahead and actually subtract the 3 here. So this way, this equation is 100% solved for x. This way, if it is completely solved for x, it will be much easier to get our x values when we plug in y. So it was 2 to the y, and then we subtract the 3 on both sides, equals x. So if we plug in a -2 for y, this becomes 1/4 minus 3. Then we convert 3 to a fraction over 4, which is 12 over 4. We get minus 11/4. I'm doing mental math here. This is simple algebra, and you guys should know how to do this. I'm not going to go into too much detail. If we plug in -1, we get 1/2 minus 6/2, which is -5/2. If we plug in 0, 2 to the 0 is 1. 1 minus 3 is -2. If we plug in 1, we get 2 minus 3, which is -1. We plug in 2, we get 4 minus 3, which is 1. Now remember how I said generally you will have the point 0, 1, or I'm sorry, 1, 0? That's not always the case, and it's not always the case because of this number right here. Since we added 3 instead of 1, this is now -2. So now you can see that this graph shifted to the left 3 units. So these are where your graph transformations come in. So that will make a difference. So let's go ahead and graph these points now. So we have almost -3. So this is very close to -3, comma, -2. So this is going to be right around here, just past the line of -3. This is also almost -3, but a little bit less than the last time, and -1. So this is going to be right around here. Then we have -2, comma, 0, -1, comma, 1, which is right over there, and 1, comma, 2. So now we get a graph that looks like this. Now this actually should be more like this, more going down, right next to the line of x equals -3. Now, if you guys remember from the beginning, this follows the direction of the graph when your base is bigger than 1. But you will notice that this graph is shifted 3 units to the left. Originally, the one I showed you in the beginning was more around over here. So, like I said, that's because of the +3 here. But anyways, hope you guys are familiar with graphing logarithms now. Best way to do this is XY tables and converting to exponential form. For additional ACT or SAT help, be sure to visit my website, www.E-ZTutoring.com. Thank you guys, and good luck.